Hi guys and girls, welcome to Aaron channel, peace be upon you, and welcome back to the last video of the screw thread tutorial course. In this video we're just going to recap everything we've learned in the course so far. So we initially started talking about screw threads and how they are all around us. There are in all sorts of different fasteners like nuts and bolts and screws. They are on bottle threads and they are in all sorts of different machines. So in this video we are going to make the male and female thread in the form of a nut and bolt to recap everything we've learned up until now. So initially starting with the bolt, we started a new part. And the first thing we need to do is draw a shaft for the thread. This doesn't necessarily have to be a bolt shape, but that's a really common shape. So we're gonna start with that. So start a sketch on the top plane, draw a circle with the circle tool, and we're going to extrude this into a circular shaft that the thread will be wrapped around. We can use the thread tables to find out some common sizes to find out the rough diameter for our shaft. And I'd recommend just making it slightly smaller than the minor diameter of the thread we want to use. The next thing we need to do is add a helix, and we are going to use this to create a sweep boss base, which will sweep the thread around the shaft. We could also make the shaft oversized and then use a sweep cut to cut the thread, and it would give us the same end result. To add the helix, we start a sketch on the bottom face, and we draw another circle fixed to the origin, so it's concentric with the shaft. Then we set the size of a circle to equal the pitch diameter, which we can also find in the thread tables. Then from within this sketch we can go to the features tab, go to curves, helix and spiral, and we can add the helix. So in terms of settings, first we need to check here on the pitch and revolution. Then we need to set the pitch, which is the distance the helix moves in one complete revolution. And this is also the distance between one complete set of the threads on the bolt. We can then reverse the direction if we need to, so that the helix is going up the shaft. And we can add however many revolutions we need to complete our bolt length. Set the start angle to 0. Then for a right hand thread, which is a standard thread, we should be going counterclockwise with our helix. But this setting can be confusing sometimes. Sometimes if we reverse the direction up here, the helix will actually be going in the opposite direction to what we think it is. So I'd recommend just saying counterclockwise for now, and then we can check that later when we've made the actual thread. So then we can press OK to create a helix, and now we want to create a thread profile which we are gonna sweep along this helix. Start a sketch on the plane that cuts through the start of a helix. It should be the right plane. Firstly we can press the F key to zoom out to see the whole model, and then add a center line down the middle of the bolt. Then staying on the center line tool, we can draw a small triangle at the bottom which will represent the profile, and we could also use the polygon tool to draw this. Ensure that the triangle is symmetrical, and add a horizontal center line across the middle of it. Then use the point tool to add a point to the midpoint of that horizontal center line. We can then use Smart Dimension to set the triangle in the correct position. So click on the point, and then click on the center line. And if we move our dimension over to the left of the center line, it should change to a full diameter dimension. And this should be the same as the pitch diameter. Then we can add some further dimensions. Add the height of the profile, which is the same as the pitch of the helix. And then we can add the angle of the triangle. And this will usually be 60 degrees, but there are many other thread profiles where it will be different. So it really depends on your exact thread. This should then make our sketch fully defined, and it should move our triangle out so the middle of it is in line with the helix. Now that we've got those base construction lines, we can select the line tool, and we can just draw the thread profile over the top of this triangle. So start from the top left and go down, and then add this small shoulder at the bottom. And that will just prevent any problems. We have zero thickness of the two triangle points exactly touching each other. Then the outer point of the triangle will be slightly cut off, and just continue adding lines until we close the profile. Then it's just a case of adding the dimensions. So the major diameter will be this outer line. And the minor diameter, it will be this inner line where the shoulder is. And we can find both of these dimensions in the thread tables. Then we may need to select the inner line. Hold on Ctrl and select the one above it, and then we can add a collinear relation. And that will just line up these lines exactly. Then the final thing we need to do is select the sketch fillet tool and just add a small radius to the bottom of the shoulder, and this can be found on the thread drawing. Now you should have your completed, fully defined sketch of the thread profile. So we can exit that sketch. Then select the sketch in the feature tree, hold down Ctrl and select the helix, and then go to the Features tab and press Swipe Boss Space. When we press OK, this should add our thread profile. Now if we look at our helix from a front view, we can see the thread is actually going up onto the left, which means this is a left-hand thread. So to change it to the right hand, all we have to do is expand the thread feature, edit the helix, and then flip the direction from counterclockwise to clockwise or vice versa. Then it's just a case of adding finishing touches. In this case, I'm going to add a ball head, just using the polygon tool and a simple blind extrude. Depending on our part, we might not actually have a bolt head. This might just be a shaft directly on another part. So in the case of this bolt, I'm gonna add some more finishing touches. I'm gonna round off these corners of the top of the bolt by just drawing a circle on the top face. Then doing a cut extrude, flipping the side to cut, and then adding a 60-degree draft angle. Then at the other end, I'm going to add a chamfer to the end of the bolt, just to allow it to locate into the hole or the nut more easily. Then the final thing to do is make the end of the thread transition into the bolt shaft nice and smoothly. To do this, we are going to select the end of the bolt face, start a new sketch and then use the Convert Entities. That will change all these outer edges into new entities within the sketch. Then select the point tool and add a point halfway up this large line. And then we can exit the sketch. We are now going to add a new plane. So if we click on the top plane in the feature tree, and then we hover over the edge until we get this cursor symbol with the 4 arrows, then hold down Ctrl and drag up the top plane, and we should add a new plane. We are then gonna zoom in and click on the point in the sketch that we just added, and this will make it so this plane cuts exactly through that point. Then we can press OK to add the plane. Then click on the plane and start a new sketch. Go normal 2 and we are just going to draw a small circle. This should be aligned vertically with the origin. So click on the origin, hold down Ctrl, click the center of the circle, and then add a vertical relation. And it should be also coincident with the bottom of that profile sketch. So click on the outside of the circle, hold down Ctrl, and click on the bottom of that sketch, and add a coincident relation. And we might need to zoom in a bit. Then all we have to do is add the diameter of the circle, and we can change it depending on how smooth we want this transition to be. We are then going to use this circle to add another helix. So from within the sketch, go to the Features tab, Curves, Helix and Spiral. And this should convert that circle into a helix, so the pitch be the same as the pitch of the main thread. Then we can set the revolutions down to something small, maybe half a revolution, because it only just needs to cut into the bolt shaft. And then we need to adjust the start angle so it's lined up with that thread profile sketch that we just drew on the end of the thread. We may also need to adjust the direction using both of these boxes, and we want to ensure that this new helix is just continuing the helix of the main thread. Then once the helix is created, all we need to do is select the helix in the feature tree, hold down Ctrl, and select that thread profile sketch, and then just add another swipe boss space, and that should add a nice smooth transition at the end of the thread. You could also combine these two helixes into one single curve before we make the main sweep, but that's a bit more an advanced technique, so all we need to do now is rename our features and save our parts. Next, we are going to use similar principles to make the female thread, which is going to be a nut. So start a new part. And we'll draw the profile using the polygon tool and the circle tool. As with the male thread, this doesn't necessarily have to be a knot. We can find out the size of the circle in the middle by looking for the tab drill size in the thread table. So I've extruded the knot profile. And the next thing I need to do is draw the helix. So it's very similar to the bolt. We can do this by starting a sketch and drawing a circle which is concentric to the hole. Then we need to set the pitch diameter, and this will be slightly larger than the pitch diameter of the bolt or the male thread. Then use this circle to create our helix by going to Features, Curves, Helix and Spiral. So the pitch of the helix should be the same as our bolt. We can set the number of revolutions to whatever we need to. We might need to flip the direction again. Set the start angle to 0. And helix direction should match that of the bolt. But as we mentioned earlier, sometimes this option can be a bit confusing. So just choose one and then we'll check it's correct later on. So add the helix and then start a sketch on the plane that cuts through the start of the helix. Now I am going to go to a cross-section view, just to make it a bit clearer. But similar to the bolt, first we are gonna add a center line going down to the middle of the hole. Then we are gonna use center lines or construction lines to draw a triangle. We are going to add the horizontal center line across the middle. And then we are going to add a point at the midpoint of the horizontal center line. We can then use Smart Dimension to set this in the correct place. So the diameter to that point that we just drew should be the same as the pitch diameter of the helix. And the height of our triangle should be the same as the pitch of the helix. And then we can set the angle, which in this case is 60 degrees. And if our triangle is coincident to the bottom of the bolt profile, then this should mean that our sketch is fully defined. So we can then select the line tool, and we can draw the thread cut profile over the top of this construction triangle. Remember to leave the small shoulder at the outside and don't go right to the end of the point of the triangle. Then just use Smart Dimension again to add the minor and major diameters. And also ensure that these two small lines are collinear. And that should fully define our sketch. And we can then exit this sketch. And we can select the helix and the sketch that we just drew. And use a swipe cut. And that should cut the thread profile into the inside of our nut. The thread is now complete. So to finish off the nut, we're just going to cut off these sharp corners like we did with the bolt head. So to do this, just start a sketch on this flat face. Draw a circle at the origin which is tangent to these outer square edges. Then do a cut extrude and flip the side to cut. Add a 60-degree trough. And that should cut off those sharp corners. And then we can do exactly the same on the other side of the nut as well. Then just rename our features and save our part. Now we can switch between the bolt and the nut documents by pressing Ctrl Tab. If we go back to the bolt, we can use this to start an assembly, which we can use to check the parts fit together okay. So from within the bolt part, go to a file, make assembly from part. And make sure we've got the bolt selected and press the green tick up here in the left. And that should add the bolt fixed to the origin. Then go to Insert Components, select the nut part, and click somewhere in the graphics area to add that. We can then mate the two parts together by zooming in and selecting a circular edge on the inside of the nut, holding down Ctrl, and then selecting a circular edge on the bolt, and then we can add a concentric mate. We can then add a parallel mate, just to stop the nut rotating. So select one of the flat outer edges, hold down Ctrl and select a similar edge on the bolt head, and then add a parallel mate. Now if we go to a cross-section view, and choose one of the views that cuts directly through the middle of our model, so the front plane or the right plane, and then go to a flat-down view of that, we should be able to see a cut all the way through our model. And we should be able to track the female thread or the nut downwards so that at some point it lines up with the male thread or the bolt. So if we zoom in, we can see that all of the threads are clear of each other. And now if we exit the cross-section view, and we click on the nut and press Make Transparent, we should hopefully be able to see that the threads are clear of each other. But we can see in this case, it's quite difficult to see. But if we look carefully, we can see that there's actually a class between them. And we can confirm this by going to the Evaluate tab and using Interference Detection And when we press calculate, we'll probably see a lot of red areas, which indicates that these parts clash together. So the nut and the bolt won't actually screw together. And the problem here, if we look at the bolt closely, we can see the threads go up into the right, which indicates it's a right-hand thread. Whereas in the nut, they're in the opposite direction, which is a left-hand thread. So these parts won't screw together. To fix this, we can click on the nut and press open part. And this will take us back to the nut part. Then we can expand the thread feature and edit the helix. And we just need to flip the direction from counterclockwise to clockwise, or vice versa. So we can see that the helix direction should be counterclockwise for a right-hand nut. But because we've flipped the direction up here as well, it actually needs to change to clockwise, so this can be quite confusing. So it's always good to check in an assembly afterwards. Now if we use Ctrl Tab to go back to the assembly, we may need to move the bolt slightly, but we should be able to move it to position where there's no interferences. And if we run interference detection again, now we can see that there are no interferences, so these parts should fit together perfectly. So now if I go to one final cross-section view, we can have a look and use the measure tool. And we can see the distance between these two threads. And we mentioned in some earlier videos that for 3D printing, I'd recommend you probably keep about 0.5 mm between your threads. But we can test this out with our prints and see what works well for your own printer. To actually print our parts, we probably need to export them in a different file format, and the most common one for 3D printers is called STL. To do this, just go back to our part documents, and then go to File, Save As. Then instead of just clicking OK, press on this drop-down says Save As Type, and we are looking for an STL file, which is here. We can also click on Options down here, and that will allow us to adjust the quality. Then if we press OK, our part will be saved as an STL, and the model will actually be converted to lots of small triangular faces. We can see here there's about 100,000. Then this format can be read by our 3D printer to make the actual print. So I'll just show you with the nut. So it's exactly the same thing. Just go to File, Save As. Click on Save As Type and select STL. And now we can see showing up there's the bolt STL file that we just saved. So if we press OK, this will now also be converted to an STL. And this time there's only 12,000 triangles, because it's a bit of a smaller and simpler part. And that's the bolt and thread parts complete. So hopefully this course has taught you some useful things about 3D printing screw threads. And now you can use these techniques to create your own parts. Maybe something like this. If you do still have any questions, then please write them in the comment below, and I'll answer them as quickly as I can. Thank you for watching. Please subscribe if you like. I hope it can be a little helpful and useful. And happy printing!